to Physics 108 class once again. So today we'll be taking the last experiment for the semester. And this experiment is on latent heat of a solid. Latent heat of a solid. So in the course of this class, I will be taking you through what we mean by latent heat. We'll discuss about the objective of this particular experiment, a particular theory based on latent heat, the apparatus needed for the experiment, the methods or the procedure that we'll be following. Then there are some exercises. For this particular experiment, there are sources of error. So we'll check the sources of error and precautions. So during the course of the experiment, we'll check how to present our results as well. So these are the things we'll check in this class today. Introduction. Latent heat. Latent heat refers to how much energy to take a kilogram of material to change from one phase to another. What do I mean by that? Okay, I said a latent heat is the energy absorbed or energy released by a substance during a change in its physical state. Now, material can change from a particular state or phase to another. Take for instance ice. Ice is in a particular state of solid, but it can change from that state to a liquid state through the process of melting. So at that point, a particular energy has been absorbed. So it changes from a particular temperature to another. So through that temperature change of melting, it changes from the solid state to a liquid state. So when we say latent heat is just it refers to how much energy it will take. Maybe it is releasing it or it is absorbing it for a kilogram of material, or particularly let's say substance, to change from one particular phase, a physical state, to another. And now there is a particular formula used in denoting latent heat. And latent heat is what we symbolize with the alphabet L. So we have L equals to Q over M. In this state, our Q is the heat required to change the phase. The heat required by that material to change from that particular phase it is to another phase. Then M is the mass of that particular material. And L is the latent heat. Now, latent heat can be categorized into three forms. Now, this categorization is according to the change in state, how it changes. So, we can naturally have a solid changing to liquid, and it can be vice versa. We can have a liquid changing to gas. It can be vice versa. And we can have solid changing to gas. So, solid to liquid is what we call latent heat of fusion. Liquid to gas is what we refer to as latent heat of vaporization, and solid to gas is what we refer to as latent heat of sublimation. Now, latent heat of fusion, this is what we refer to as melting. Remember I said from solid to liquid, melting. So if a particular material undergo latent heat of fusion from solid to liquid, that means it has undergone it has melted. Now, it says latent heat of fusion or melting of a solid is the quantity of heat that's required to transform that particular solid to liquid at its own melting point without any variation in temperature. Now look at this chart. It shows the different change in states that can have, that our material can undergo, that different substances can undergo. Now we have from solid. Look at the first one, sublimation. It can go from solid to gas. So it means you say it has sublimed. Then solid also can go from solid to liquid. That is melting. That is like the case of our eyes. Then we can have we can have liquid back to solid. That is freezing. Some of us that like, they'll say, I want cold water or ice water. Now this particular one is not even ice water. Block. For people who they like to take ice cubes in their drink. So those particular ice cubes has undergone freezing from liquid to solid. Then we can also have from liquid to gas. That's vaporization. Then we can have it vice versa as well. That is from gas to liquid, condensation. So these are the different change in state or change in phase of materials that we have. Now for this particular experiment, the objective of this experiment is to determine the melting point. At what point does a particular material in question melted? So we are trying to determine the melting point of a particular solid. The melting point of the solid that will be taken into consideration. Now there is a particular theory which says the change from solid to liquid state of a compound, that is melting. In heating is called melting, and the temperature at which a solid in its pure form melts is called the melting point. That particular change in state, melting, but there's a particular point that state will be reached, and that particular state, that point is called melting point. Now every pure solid has a characteristic melting point. Every pure solid, underline the word pure. Therefore, determination of melting point helps in identification of the compound. Presence of impurities lowers the melting point of the solid. So if there are impurities in a particular substance or material you are trying to get the melting point, the presence of those impurities will lower the point at which that material will reach its melting point. So the melting point, therefore the melting point now serves as a criterion of purity of a compound. They now use melting point to check if a particular compound is pure. That is in the lab. Because if there are impurities in that compound, the melting point will lower the melting point. But if there are no impurity in that particular compound or material, you will know, as long this theory actually applies to people that deals with lab work, that checks for that are used to checking for the pure materials in a particular checking pure materials. They're trying to detect materials in their pure form. Just like when we say gold, there are fake and there are real gold. So when you see people that works in lab, they can detect pure gold. Yes, and they can detect the fake one. They can try to use the issue of this melting point to detect which one is in the original pure form and which one is adulterated. So the apparatus needed, we need a test tube, we need a thermometer, we need a naphthalene ball. Yes, the naphthalene ball is a solid substance, and I know some of us will be wondering, what is naphthalene ball? Naphthalene ball is what we call camphor. You know, that small round this thing that we used to put inside our clothes so that it can smell nice in our wardrobe. Our parents, they put it inside their own cupboard of clothes. So that is naphthalene ball. We call it camphor. We have a beaker, we have water, we have triple stand, we have Bunsen burner, we have meter stand. Most of the time, this particular experiment, what the solid substance that is usually made use of is ice cubes. But when I checked through the workbook for this particular experiment, this one is workbook from the department, I realized what was being used was naphthalene ball. So that was why I, didn't use the ice cube. Even if you go online, most of the experiments you'll be seeing on this particular experiment, what they used was ice cubes. Just few used naphthalene ball. So the procedure to follow. So it says, first one says, measure the mass of the calorimeter using the electronic balance. Yes, you'll be provided with an electronic balance using measuring the mass of a material. So you just place the calorimeter on the electronic balance and it will give you the mass of that particular thing you put on it. So you measure the mass of the calorimeter using the electronic balance. It's already in our apparatus that you will be provided with a test tube. So you fill the test tube to about half full or even more than half with naphthalene and insert a thermometer. You are inserting a thermometer, that naphthalene, most of the time it will have been grounded. It will have been grounded so that it will be easy to dissolve and get the melting point. It will have been grounded. So you fill the test tube to about half full with naphthalene and insert a thermometer. The thermometer is used to check the temperature. So you are trying to check the temperature of the naphthalene at the beginning of the experiment before it's melted. That is the solid we want to check the melting point. So at that particular point you are using it, you need to check the temperature. The fact that it has been grounded does not mean you have changed, the temperature has changed. It is still the naphthalene. It has not undergone any heat. You have not undergone anything that will affect the temperature. So at that particular point you insert the thermometer to check the temperature. Then you immerse the test tube into a beaker of boiling water. At this point where you are filling your test tube with naphthalene and checking the thermometer, you already have a boiling water with your test with a beaker. You already have it, boiling water inside the beaker. In fact, you will have it already under it, fire. So you immerse that test tube that you are holding that you have put your naphthalene inside. You now insert it, you immerse it. When you say immerse, just like you dip it inside the water. Immerse the test tube into a beaker of boiling water until all the naphthalene has melted. So you place that test tube. You will use you will have to hold it with something, put inside the boiling water. You are using the boiling water to change the temperature of that naphthalene to melt it. So at that point you are already, it's already absorbing it. It's changing. The temperature of the naphthalene is already changing. So it's undergoing melting. So there will be a point where all the naphthalene will have melted. So that is that point we are trying to check in this experiment. So you remove the test tube from the bath. The bath here is that boiling water. The beaker of boiling water, that's the bath. So you remove the test tube from the bath. Then you dry the outside quickly with blotting paper. It means you dry that your test tube. You will have water around it since you are just removing it from the boiling water. So you clean it, you dry the water with a blotting paper. Then you hold the test tube tightly in a retort stand. That retort stand is just to help you hold the test tube so that it won't burn your hand. Because if it's too hot for you, you might unknowingly just drop it. And everywhere press it tightly in a rheostat. After holding it, you take temperature reading at every minute interval. You are trying to check it every minute interval until all the naphthalene has melted. Make note of the temperature T1 as soon as the compound begins to melt. Make note of the temperature T2 as soon as the compound is melted completely. You have seen that those two temperatures are different. The first one taken when it started melting, and the second one will be taken when it has melted completely. So the average of the two readings gives the correct melting point of the substance. Now look at this circuit diagram now. You have a Bunsen burner, you have a wire gauze on the Bunsen burner, then you have a beaker. You see the beaker, inside the beaker there is water filled in it. So the Bunsen burner is to boil that water inside the beaker for you, and you can see the thermometer inside the beaker. You have a stirrer. This is just a typical setup that you will likely see for this particular experiment. But you see there is circuit diagram in your practical manual that will guide you on what to do and how your setup will look like. So for this particular experiment, I say plot a graph of values of temperature in degrees Celsius against time. So from the graph, you are going to determine the slope of that particular graph. You are going to determine the intercept on the vertical axis. Then you are going to state the sources of errors in the experiment and precautions taken to minimize those sources of error. Now, in this particular experiment, the sources of error in the experiment, you have errors in the melting point measurement occur due to experimental errors such as heating the water bath too rapidly, poor alignment of the thermometer and sample. Some people, they will just, they will not dig that thermometer as it is supposed to be inside the sample. If the thermometer is nowhere placed in the sample, in the substance you are trying to check the melting point, how do you think your reading will be? So the first source of error is the experimental error due to the heating of the water bath too rapidly, poor alignment of the thermometer and the sample. Then we have another one, which is the environmental error. When some factors in the environment is determined, this is when some factors in the environment affect our experiment. Now, such factors is the wind. The wind might cause incorrect measurement, and that was why in the last semester I told us it is not advisable that for any of your experiments you perform them at the slab beside the window. It is most advisable that you use the tables, and even don't make use of your fan. The wind blowing either from the fan or from outside, it will affect the measurement. So that is called an environmental error. Then we have the precautions. Now, precautions we have: I ensure that test will be filled to at least 1/3 of its length. I ensure that the rate of heating is controlled so that the melting point can be recorded accurately. Yes, you do not apply too much heat. As long as that particular water in the beaker it has reached melting point, 100 degrees Celsius, then you are good to go. The bulb of the thermometer should be kept surrounded with crushed naphthalene. Now I said it's crushed naphthalene. We will have crushed naphthalene for you so that you will be able to put it in the test tube. Then the naphthalene should be stirred regularly to keep a uniform temperature. If you pour the naphthalene in the test tube and you immerse the test tube into the beaker, it is advisable to always stir the naphthalene, because the naphthalene at the below the test tube, at the ones at the bottom, will attract that heat first. The heat from the boiling water will first reach those ones at the bottom side of the test tube before it gets to the ones on top. So it is always advisable that you stir, continuous stirring. You stir continuously so that the temperature, will be uniform throughout the naphthalene. So the standard temperature should be noted by keeping the highs in line with the level of the mercury. When the person in charge of the thermometer should be someone that is always at alert and not playful. So, like we always do, you have yourselves in groups. So when you have